The first 15 agents in this series focus on producing static artifacts. They ingest a prompt and output a finalized block of code, a structured dataset, or a polished report. Agent 16, the conversational agent, delivers a longitudinal human relationship. Building this requires addressing the stateless nature of raw large language models. Without modification, these models possess zero context about the user. Every prompt is a fresh start for the system. This mirrors visiting your local coffee stop every morning for 2 years, receiving the exact same blank stare from the barista every single time. Junior developers often attempt to solve this amnesia using the context window fallacy, pasting the entire history of a chat into the background of every new message. That approach collapses. Compute costs multiply, response times stretch, and the model hallucinates as vital details get lost. A relationship requires engineered memory. Without it, the interaction is merely a sequence of isolated transactions. Directly connecting a stateless, probabilistic text generator to a user in high-stakes environments, like healthcare or customer support, introduces unacceptable risk. Unconstrained models prioritize conversational fluency. When confronted with sensitive topics, the underlying math will improvise a response, regardless of the potential for harm. Agent 16 solves this through a hard architectural barrier. Generation is downstream of policy. This requires the system to verify intent and enforce safety rules before the language model is ever allowed to process the input. Professional implementations differ from amateur attempts by blocking unsafe prompts before generation begins, rather than trying to filter a response after it is already written. The agent's memory and persona function as strictly engineered plumbing. Safety is a structural wall built in front of the model. This 6-stage vertical pipeline executes in the fraction of a second between a user's message and the agent's reply. Stage 1 is the safety sentinel. This component is the absolute first point of contact for any incoming prompt. The sentinel functions as a hard, deterministic circuit breaker, operating completely independently from the AI's creative engine. If the sentinel detects a severe trigger, such as intent for self-harm, it activates a crisis protocol. The system bypasses the LLM and delivers a hard-coded escalation response. The code implementation shows this interception. The safety check evaluates the text immediately, returning the crisis protocol if a failure occurs and preventing further processing. If the input clears the sentinel, it passes to stage 2, the dialogue manager. This is the executive air traffic controller of the conversational turn. The dialogue manager coordinates the upcoming memory polls and persona constraints rather than blindly passing the user's text forward. The first microseconds of computation determine if the model has the right to speak at all. The dialogue manager initiates the retrieval augmented dialogue loop, or RAD loop, to manage context without hitting token limits. The RAD loop relies on a dual memory hierarchy. Stage 3 is working memory, a short-term scratchpad residing in RAM. Working memory operates as a low-latency, first-in, first-out buffer. It maintains the raw text of recent exchanges while summarizing older messages within the current session. We implement this using a conversation summary buffer memory object, balancing current session awareness with execution speed. Stage 4 is semantic memory, which facilitates the long-term cross-session relationship. When a user shares a durable fact, like an upcoming exam, the system translates that fact into a high-dimensional vector. Through cosine similarity, the agent recalls that specific detail weeks later, because the vector matches the semantic meaning of the user's new prompt. This requires vector database infrastructure, using tools like FACE and OpenAI embeddings to archive and retrieve these associations. The architecture combines immediate session coherence with the archival recall of semantic memory. Stage 5 is the persona engine, the layer that dictates the agent's tone. Tone is an architectural choice. Large language models do not possess an inherent personality. Persona is controlled bias. It is a set of persistent behavioral constraints installed to limit the model's output to a specific behavioral region. Finally, in stage 6, the language model generates its response. This occurs only after safety, memory, and persona are applied. The turn continues after the response reaches the user through a final mechanism, the asynchronous writeback. The system extracts new facts from the interaction and saves them to the semantic memory vector store. This memory update step finalizes the loop by committing the interaction to the agent's long-term record. A conversational turn ends only when the system permanently alters its own memory. This constrained pipeline is the standard for high-stakes deployments, including clinical health companions. Enterprise support engines use this deterministic safety structure to ensure compliance and reliability. However, Agent 16 is a strictly reactive entity. When the user disconnects, the agent stops. It does not wake up autonomously or pursue background goals while the session is inactive. The conversational agent is a cognitive mirror. It maintains state and enforces safety, but relies on human input to drive the process forward. Agent 16 converts a stateless text generator into a safe, predictable, and relational interface. In our next video, we build Agent 17, the content creation agent, shifting the focus from human relationships to the generation of publishable multimodal artifacts. To study the Python code powering these memory hierarchies and safety gates, refer to 30 agents every AI engineer must build. Mastering the conversational plumbing provides the necessary state management for human-facing AI.